Okay, so actually this lightning talk is about a novel kind of embeddings that we have developed at Facebook. As you can read from the title, these kind of embeddings are resistant to misspellings. This work has been done by a bunch of people that you can see actually in the slide here. Is a collaboration between the search team at Facebook and Facebook AI Research. And basically, the reason why this work started in the search team is because we wanted to, so in our, let's say, spell corrector module, we are using a bunch of features, and some of the most important features are word embeddings. And of course, a natural extension of word embeddings in the case of, let's say, in the context of, let's say, the spell checker, is to make sure that our embeddings are resistant to misspellings. Also because in most of the cases, misspellings are out of vocabulary words that do not possess any embeddings. The work has been inspired mainly by fast text that I'm pretty sure all of you know. And actually some of the authors of the original fast text paper is actually also, you know, members of the research team that developed MOE, misspelling oblivious embeddings. And as you probably know, the main idea of fast text is to, let's say, embed words also on the basis of the n-grams that word has. And so basically already fast text is kind of resistant to out of vocabulary words. But is not really resistant to misspellings, as you will, I mean, I can tell you more later during the poster session. So we actually added an additional term to the loss that is kind of supervised, and basically we used some of the training data that we have from Speller, where we basically, you can think of the misspelling oblivious loss as a way of, let's say, putting closer together, let's say, spelling variations of the words, let's say, I mean, according to how misspellings are actually made by humans, and to, let's say, separate as much as possible things that are like let's say, misspellings. So the final MOE loss is the one that you can see in the slide, and I mean, you can think of MOE as a sort of multitask learning where you learn at the same time word embeddings and misspellings embeddings. And actually we share also parameters. And actually the MOE scoring function is basically the same as the fast text one. We also split the words in let's say, n-grams to make sure we can relate subwords information. As training data, we used pretty much the same training data that we were using in fast text. And actually, let's say we added to this, as I said, I mean, misspellings that were obtained by mining, let's say, the way misspellings were corrected by real users on our search engine. You can see some examples of the training data here, and as you can imagine, they are misspellings, as we said. So, again, I cannot really go deep into details, but as you can see, for instance, already from some anecdotal examples, take, for instance, a misspelling of the word smallest. On the left-hand side, you can see how fast text, I mean, the nearest neighbors are produced by fast text, and on the right-hand side, the nearest neighbors produced by MOE. And as you can see, fast text is not correctly identifying that it's a misspelling of the word smallest, whereas MOE does that also in, let's say, in conjunction of, of the fast text loss. Yeah, another example here. And this is actually a 2D visualization that, show how the resulting space is actually there. We actually tried MOE on a part of speech tagging, let's say, extrinsic task. And let's say, as expected, let's say when you apply MOE, when you use MOE embeddings versus fast text embeddings on a misspelled text, we can recover almost, not all, but almost all the loss, sorry, the losing precision of let's say, a part of speech tagger that uses just fast text. And again, I can give you more information at the poster. Thank you.